All right, hey everybody. All right, hope you guys had a great weekend, a great um relaxation time and everything. Um Happy belated Columbus Day. You know, I know we didn't get to see each other in person this week, you know, due to the holiday and everything, but I will see you guys all next week. Your test has been graded. All right. I have it on me. The next time that I'll be in person in tutoring will be Friday and Saturday. You guys are welcome to book me if you like. Um, Part of that, if you want to get your test early, you're more than welcome to book the appointment and see me. You know what? I left out that next week I'll be in person on Monday as well. Sorry about that. So I will be in person on Monday as well in tutoring. So if you'd like your test back then, you can also book me and get that back at that time as well. And in Tuesday on in person, if you don't have the test back before then, I'll give it back to you that day. No problem. All right. Um the test was okay. There's definitely room for improvement, right? But it's not all terrible, all right? I know that I've been giving you guys homework. Um, I am lenient with your due dates for the homework, right? So I understand that some of you might have homework that you haven't got to look at as yet. Understandable. All right. Just asking you guys, meet me halfway. Please stay on top of your homework. You know, um, it's okay if you don't remember how to do everything, right? That's what the videos are for. Rewatch the videos, do the homework. If you and by the way, the video titles have the same title as the homework, right? So it's kind of easy to find which video goes with which homework. Um, if you rather have help with the homework, please attend tutoring. All right. There's in person and online. They meet at the exact same time. In person is 11 a.m. to 8 p.m. Monday through Thursday, 12 p.m. to 6 p.m. Friday and Saturday. All right. And again, it's in the same building that we have class, just on the third floor, room 303. And for online, just make the appointment, then they'll send you over the link, right, in the confirmation email. And then you'll be good to go. All right. Other than that, right, today is the end of the week. It's Thursday, right? So we all know that next week will be pantry. So if you guys want to take part in that, please do. Um, that's all I could think of right now to say. Is there any questions from anybody? Does anybody have any homework questions you guys would like to go over? I accidentally opened up your homework a little too early, right? Like I opened up, I want to say on Monday, and it should have been opened up last night. Apologize for that. Right. So aside from the stuff for homework tonight, do you guys have any other older questions? Anything that you guys would like to see or you'd like to go over? So we had it already, right? We had it in class. That was our test. Yeah. Awesome. 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 All right. Also, just to let you guys know, this is more so um a thing on Tuesday, right? Like even though class does end at like what is it, 4:45 or something like that, right? I actually stay back a little bit because it takes me a while to upload the class online. right? So you guys are welcome if you want to stick around, knock out homework together. You guys could talk in front of me, like you can ask me questions. That's all cool. If anybody's interested in doing that, just putting that out there. All right, awesome, awesome, awesome. All right. So just open up to questions right now. If anybody has any questions, anything you guys want to go over, any like one or two homework questions that is just like, dang, I done tried everything and I can't get it. Like now be that time to ask, you know? It's being recorded too, so it's okay if you can access the question and then like just tell me it, and then like you can rewatch this again to see the process if you're traveling or something right now and you don't have your notebook. I understand. All right. Yeah, anything at all. Any questions? No pressure, no pressure. All right, so we got one right here. All right, I'm gonna need you to verify if the way that I'm interpreting this is correct or not. All right. So I have R. Oh, sorry about that. So I have R to the third power, and then S to the 10th power, and then T. I'm gonna do it in script to the third power over R to the fifth power, S to the third power. I'm gonna do it in script again, T to the third power. Am I correct in writing this? Or did I get something wrong? Okay. All right. So I assume, and tell me if I'm wrong about this. I assume that what they want us to do in this question is they want us to reduce, right? Simplify the quotient, in other words, right? So awesome. So how I would do that, right, is I would take each variable individually, each variable, right, and I would just divide them straight out, right? And the way that I divide exponents, right, is I write down the exponent and I subtract their powers, right? I subtract their powers. So for example, this is going to become, I'm sorry, well, I don't know why that keeps happening. This is going to become R, right? And then it's always top minus bottom, right? Top minus bottom. R to the 3 minus 5 power, that's a 5. And then times S to the 10 minus 3 power, and then T to the 3 minus 3 power, right? And then right after that, let's see what happens, right? This is going to become R to the negative 2 power, and then times S to the 7 power times T to the 0 power, right? Now, we know that anything to the 0 power is just 1, right? Remember that property? So this whole thing right here just becomes 1. So all I really have is I just have the R to the negative 2 power and the S to the 7 power. Now, here's the thing, right? It's illegal for me to have negative exponents, right, in my numerator, right? So what's going to happen is that R to the negative 2 power is going to become 1 over R to the positive 2 power. So I'm putting in a denominator, in other words, right? And I still have my S to the 7. You know what? Let's just put it over 1. And remember how we multiply fractions straight across? So what does this become? This becomes S to the 7th power over r to the second. And then this will be my answer to the whole question. Did that make sense? Awesome. Awesome. All right. Any other questions from anybody? Anybody else? Find the product? Okay, okay. Let's do a find the product question. All right. I just need you to confirm with me if what I'm writing is correct. So I have, oh shoot. Sorry about that. Sorry about that. So you know what? Let me change the color too. Change the color. Okay. So I have 6xy. Okay, hold on. I have 6xy, and then I have negative 5x to the 10th power. I'm guessing times y. And like they want, okay, got you. So like they want like something like this, like c times x to the a times y to the b, something like that. Okay. All right. So, excuse me. In this question, what I understand, right? We want to figure out what is C. Oops, sorry about that. What is C? What is A? And what is B? That's what we're looking for in this question, right? After we multiply these together. All right. So let's multiply them. Remember how we do this, right? We do numbers with numbers, variables with variables, right? So what is 6 times negative 5? Right? So that's negative 30. Excellent. Oops. I don't know why this keeps happening. That's negative 30, right? Now I want to multiply my x's together, right? So I have x times x to the 10, right? Remember that whenever we multiply our variables together, we add their exponents, right? So this is like a baby 1. So it's going to be x to the 1 plus 10, right? Right. So then let's call that negative 30 x to the 11. What am I going to put on the y? Somebody tell me. What's that power that's going to be on the y? Remember, it's the same thing. Oh, the 11 is on it? Right, 2. Right? So this is going to be 1 plus 1. That's coming from the exponents right here. And then that's going to just simplify down into 2. All right? So then now for your homework in particular, right? I feel like they're asking for like what is C, what is A, what is B. So sorry about that. So C in this case, right, which is the constant, is going to be the negative 30. A in this case, which is going to be the exponent on the x, is going to be 11. And B, which is going to be the exponent on the y, is 2. And then that's it. Awesome, awesome. All right. So let's jump into our lesson for today. Probably say again, I'm sorry. Okay. At the end we can do some more questions together, no problem. Okay. All right. So before we jump into the full lesson for today, I just want to give a light refresher of what we looked at last week. Very quick, very brief, right? So this chart right here is our general strategy, right? Our general strategy for factoring, right? So always the first thing that we do, I'm gonna do this in pink, right? Always the first thing that we do, right, is we always start off looking for our GCF. No matter which question we have, whether we have one term, two terms, three terms, four terms, you always start off and see if there is a greatest common factor. And if there is, pull it out, and whatever's left over, then that's what you're going to factor using one of these three methods here, right? So if you have a binomial, right? Remember, binomial means that you have how many terms? Two terms, right? Binomial means you have two terms, right? How do we factor that, right? We factor that using the difference of two perfect squares right here, right? So when the two terms are being subtracted from one another, such as a squared minus b squared, then we know that our factors are going to be, for example, a minus b times a plus b. All right. If you have a sum of squares of perfect squares, so for example, say you had 9 plus y squared. I'm just making it up. 9 plus y squared, right? We can't factor that. So sums of perfect squares do not factor. Remember that. And then again, I'm not asking you guys about the cube stuff, so don't worry about that. Right? Trinomial. Let's remember, right? Trinomial, that's gonna have how many terms? Tri means three, right? So three terms. All right. My mistake, I got a little carried away. No problem, no problem, no problem. All right, just catch up with the recording. Okay, anyway, trinomial, right, has three terms, right? Three terms. And then we have two types of trinomials, but you can use one single method to work for all of them, right? When you have a trinomial of this type of form, x, oh shoot, so sorry about that. Just move that back over. When you have a trinomial of this type of form, which is x squared plus bx plus c, right? You can factor it just like this. You know that there'll be two parentheses, like so, and there'll be an x here and an x here. And all you have to do is figure out two numbers that multiply to give you the c term, but when you add those two terms together, they'll give you the b term. That's the trial and error method, right? Or, right, you can use the tricky method, like when you have the a and the c perfect square trinomials. That's another way of doing it, right? So if you have, and remember, it has to be a perfect square, right? So a and c has to be perfect squares. So I'm talking about 9. I'm talking about things like 16, right? 25, a number where you multiply it by itself and it gives you a large number, perfect square, right? Then you can use one of these tricky methods right here if you want. Or if you just want to simplify your life, you don't want to remember all of this, you feel like this is too much, AC method will always work for everything, right? If you want the simplest way to do it, you see three terms, go straight to the AC method. You will never go wrong with the AC method. It works for everything. All right. Last but not least, when we have a polynomial, meaning three or more terms, or more than three terms, excuse me, more than three terms. So we're talking about four or more terms, right? In this class, we're just dealing with four terms. So I'm just gonna keep it simple with you guys. Call it four terms, right? We factor that by grouping, right? Group the two terms on the left, group the two terms on the right, greatest common factor, right? And then we just put everything together, right? That's how we do this. All right. Is there any questions on this? Any at all? I know that last time we met, I showed you this, but I actually didn't give you the homework for it. Now you have it. So you guys might have already completed this. That's okay. All right. I just wanted to show that one more time, just to make sure everybody got it down packed. All right. And then now let's jump into what we're gonna do today. All right. Just bear with me 1 second, please. Okay. So I want to switch gears just a little bit, right? We're still going to talk about polynomials, right? But I want to talk about polynomial equations, right? Polynomial equations. That's what I want to talk about today. All right. So polynomial equation. So a polynomial equation is an equation that contains a polynomial expression. That's what we've been doing, polynomial expressions, right? The degree of the polynomial equation is the degree of the polynomial, right? So you might be looking at this as saying equation, expression, right? What's the difference, right? The difference, I'm going to show you right now, is the equal sign, right? So whenever you have a polynomial equation, right, you're going to have the polynomial expression here. I'm just going to call it poly expression for short, just for short, right? And it's going to be equal to something. Often it's going to be equal to a number, right? Often some type of number will be here. Or it could be another polynomial expression altogether. That's possibility too. Polynomial expression equal to another polynomial expression, right? And these equal signs that you see right here, that's what makes it an equation, right? I'm solving for a variable, right? That's what makes it an equation, right? I just want to give you guys an example real quick just to make it clear. Okay. So we are now going to solve polynomial equations of degree 2. A polynomial equation of degree 2 is called a quadratic equation. All right, so listed below are some examples of quadratic equations. So for example, you have x squared plus 5x plus 6 is equal to 0, or you have 3y squared plus 4y is equal to 10, or you have, for example, 64u squared minus 81 is equal to 0, or you have n times n plus 1 is equal to 42, right? Quadratic equations. I kind of want to put a little definition on that for you, just to make it more clear. So quadratic equation is an equation of the form ax squared plus bx plus c is equal to 0, and this is called a quadratic equation. Just so we're clear, a, b, and c are real numbers, and a cannot equal 0, right? A cannot equal 0, because then it would be a linear equation. That's not what we're talking about here. It's not what we're talking about here. All right. Next, I want to introduce you to to something. I want to introduce you to the zero product property. We're going to use this to find our answers, right? So pay attention to this, right? If A times B is equal to 0, then either A is equal to 0 or B is equal to 0 or both of them are equal to 0. All right? That's called the zero product property. Right? And we're going to use that to answer our questions here. All right. So I want to show you guys an example of how we're going to use the zero product property to answer our questions. So let's take this question right here, for example. So I have, let me just scroll down real quick. I have 5n minus 2 times 6n minus 1 is equal to 0, right? And what I want to do is I want to solve for n. So this is how I solve for n right here, right? I like to put a little line here, right? And I'm going to set each one of these individually equal to 0. So for example, I'm going to have 5n minus 2 is equal to 0. And on the other side, I'm going to have 6n minus 1 is equal to 0. And in both of them, I'm going to solve for n. So I'm going to add 2 over here. And what I do to one side, I must do to the other. So now I have 5n is equal to 2. And then I'm going to, I'm going to divide by 5 to get n by itself. And what I do to one side, I must do to the other. So I have n is equal to 2 over 5, right? I'm going to call this n1, right? Because I'm going to have two n answers here, right? I'm going to have the one on the left and the one on the right. On the right-hand side now, I have 6n minus 1 is equal to 0, so I'm going to add 1 over here. But what I do to one side, I must do to the other. So now I have 6n is equal to 1. And then I want to divide by 6 to get n by itself. But what I do to one side, I must do to the other. So now n2 is equal to 1 over 6. Both of these are my answer. All right. So in web work, they'll probably ask you to separate the answers by a comma or something. So, you'll just type in like 2 over 5, comma, 1 over, and then you'll be good to go after that. Right? Is there any questions on this? Does this make sense? All right. Let me give you guys one to try. I don't want to hog all the fun for myself. All right. I'll let you guys try one. I like this question right here. Okay. You just kind of pull this down a little bit so you can see. And go ahead, try it out real quick. Try it out. Solve for m. Solve for m. Awesome. All right, let's take a look at this. Let's take a look at this. Let me come back. All right. I believe those answers that were found are correct. Let's take a look how to do this, right? So I'm going to set each one of these individually equal to 0. So I have 3m minus 2 is equal to 0. And I have 2m plus 1 is equal to 0, right? So what I want to do is I want to solve for m. So I'm going to add 2 over here. And what I do to one side, I must do to the other. So now I have 3m is equal to 2. And then I want to divide by 3. And what I do to one side, I do to the other. M is equal to 2 over 3, right? On the other side, right, let's call that M1, by the way. I apologize. Let me call that M1. On the other side, I have 2m plus 1 is equal to 0. I want to solve for m, so I'm going to subtract 1 from over here. If I do to one side, I must do to the other. And now I have 2m is equal to negative 1. After that, I'm going to divide by 2, because what you do to one side, you must do to the other. So now I have m2 is equal to negative 1 over 2. And then these are my answers. Are there any questions on this? No worries, Franklin. All good. Any questions on this? Everybody understands? All right, let's keep it moving. Let's keep it moving. Let's keep it moving. All right, so we're gonna take it up a notch, just a little bit. So we want to solve quadratic equations by factoring. The zero product property works very nicely to solve quadratic equations. The quadratic equation must be factored with 0 isolated on one side. So we must be sure to start with the quadratic equation in standard form, ax squared plus bx plus c is equal to 0. Then we must factor the expression on the left. So we want to put it in the standard form, ax squared plus bx plus c is equal to 0. Then we factor, and then we do our zero product property, which is this, solving for 0, and then we get our two answers, and that's it. All right, let's try it out. Let's try it out. I'm going to start off with a little bit of a complicated one. But just follow me along. Follow me along. I'm going to try and make this simple. All right. So for this question here, I have 2y squared is equal to 13y plus 45, right? 2y squared equal to 13y plus 45. Now, I want to put this in standard form, right? And we remember what standard form is, right? Standard form is the a, let me think where I want to write this. I'll write it up here. So standard form would be like ax squared plus bx plus c is equal to 0. That's the standard form. But right now, what I have is not in standard form, right? So I'm going to move everything to one side to get it in standard form. So I'm going to subtract 13y from over here. But you know I have to be fair, right? What I do to one side of the equation, I must do to the other side of the equation. So I'm going to subtract 13y from over here. So now what do I have? I have 2y squared minus 13y is equal to 45. After that, I want to subtract 45 from over here. And what I do to one side of the equation, I must do to the other side of the equation. So now what do I have? I have 2y squared minus 13y minus 45 is equal to 0, right? Remember, these are not like terms, so I can't combine them. I can just rewrite them next to each other, all right? Okay, now I'm going to inspect it. I'm going to inspect it. I have 2y squared minus 13y minus 45. Do I have a greatest common factor here? What do you guys think? Is there a number or variable that goes in to every single term, all three terms here? A single number or variable that can do that? Don't say one. Can anybody see anything? Right? There's nothing, right? So here's what we want to do. We want to factor this. We want to factor this. So remember how we factor it? We use the AC method, right? So let's review the AC method real quick. So again, remember that this is in standard form, which is ax squared plus bx plus c, which is equal to 0. So in AC method, we're going to do a times c, which in this case is what? 2 times negative 45, which will give me a negative 90. And what I want to do is I want to get my b term here, which is a negative 13. So now I want to figure out two numbers that when I multiply them together will give me a negative 90, but when I add them together will give me a negative 13, right? Now, let's make some observations here, right? I have a negative 45 in the original question. That means that my C term is negative. That means that one of my factors has to be positive and one of my factors has to be negative. Because the only way to get a negative answer through multiplication is if one answer is positive, one answer is negative. I'm looking at my B term over here. My B term happens to be negative, right? That's a negative 13 in front of the Y. That being said, I know that in the two numbers that I'm going to figure out and find the factors for, right? The bigger number, the larger number is going to be negative because the B term is negative. All right. Let's just keep that in mind. Let's just keep that in mind. All right. Now, 90 is kind of a large number for me personally. So I'm going to have to use the factorization tree to make life a little bit simpler. So I know that 2 times 45 will give me 90. I'm going to break down 45. I think 45 could get broken down into, I think, 5 times 9. And I think I could break down the 9 into 3 and 3, right? So using these four numbers here, 2, 5, 3, 3, I have to figure out some combination of them where if I multiply them together, I'll get negative 90. When I add them together, it's going to give me a negative 13. So I'm thinking, 15 and 6. Let's see. If I did negative 15 times 6, right? I do get negative 90, but negative 15 plus 6 is going to give me a negative 9. That's not going to work. That's not going to work. Let's try, how about 18 and 5? 18 and 5, right? So I'm thinking about a negative 18 times 5, right? That is the negative 90. But how about negative 18 plus 5? Let's take a look, right? That's going to give me the negative 13. So that's it. So now what do? I'm going to rewrite my original equation. I have 2y squared, but instead of the negative 13y, I'm going to do a negative 18y plus a 5y minus 45. Excuse me, I'm sorry about that. 45 is equal to 0, right? And then remember, I want to factor by grouping. I have four terms now, so I'm going to group these together. So I have my left group and I have my right group. On my left hand side, greatest common factor there is what? 2y. And what's left over? Remember, whenever you factor out of 2y, it's like you're dividing by 2y. It's like you're dividing by 2y, right? 2's will cancel out, y in the square. That leaves back just y. A negative divided by a positive is a negative. 18 divided by 2 is 9, and the y's will just simply cancel out. On the right-hand side, I have 5y minus 45. Greatest common factor there is a positive 5. Remember when I factor out a positive 5, it's like I'm dividing by 5. It's like I'm dividing by 5, right? What's left over? 5 and 5 will cancel out, leaving back y. A negative divided by a positive is a negative, and 45 divided by 5, I think, is 9. And remember, this is an equation, right? So it still equals 0. Right after that, greatest common factor, once again, I'm going to factor out that y minus 9 that they both have in common, both terms has in common. And what am I left with? I'm left with the 2y plus 5. And both of these are equal to 0. So now we're back to the zero product property, right? So I'm going to set both of these individually equal to 0. So I have y minus 9 is equal to 0, and I have the 2y plus 5 is equal to 0. And then just solve for the variables. So in this case, I'm solving for y. So I'm going to add 9 over here. What I do to one side, I must do to the other. So now I have y1 is equal to 9. On the other side, on the right-hand side, I'm going to solve for y. So I'm going to subtract 5 from over here. What I do to one side, do to the other. So now I have 2y is equal to negative 5. Then I want to divide by 2. What I do to one side, do to the other. So I have y2. I'm sorry, they're not on the same line. I have y2 is equal to negative 5 over 2. And then this will be my answer. All right, is there any questions on this? Any at all? Anybody? It's clear? All right, let me give you guys a opportunity to try one. All right, there you go. I understand. Yes, it is quite a few steps. Yes, yes. But basically the only new step that we're learning today is the zero product property, setting those final factors individually equal to zero. That's our new step that we're learning today. And everything else is the same that we've always been doing it so far. All right, we're just trying that out. Before the class ends, I'll show you a much quicker way to do these types of questions. But for now, we're building it up, right? We're just building up to that.
My nose itch.
Oops. Okay. All right, let's take a look. Let's take a look. Let's take a look. All right. Remember that I want to get this in standard
What is
form.
that? What is that?
Standard form. What is standard form?
Can I laugh?
Huh?
Can I laugh?
No, she gotta come back.
Can you be laugh?
Relax.
So,
You're not gonna sleep here today.
Tell me about that.
gotcha. Sorry about that. So our standard form is ax squared plus bx plus c is equal to 0, right? I want to get my question in standard form first before I can solve it. So let's begin with that. I have excuse me, I'm sorry about that. I have 3c squared is equal to 10c minus 8. So what do I want to do? I want to solve the equation basically, but I want to put everything on one side first. So I'm going to subtract 10c from over here. But what I do to one side, I must do to the other. And now what do I have? I have 3c squared minus 10c is equal to negative 8. And what do I want to do after that? I want to add 8 to it. What I do to one side, I must do to the other. So now what do I have? I have 3c squared minus 10c plus 8 is equal to 0. Right? After I get that equation right there, what do I want to do? I want to factor it. So let's do the AC method, right? So I'm going to have A times C, which in this case for me will be what? 3 times 8. And we know 3 times 8 is what? 24. Let's keep going. And I have my B term is equal to negative 10. Now I want two numbers that when I multiply them will give me a positive 24. But when I add them together will give me a negative 10. Right? Now, I know that my C term here happens to be positive, so that means what? That means that both of my numbers are either going to both be positive or both be negative. But how do I know which one is which, right? I look at my B term. My B term is negative, so therefore I know that both the numbers I'm looking for are negative, right? So that being said, I want two negative numbers that when I multiply them together will give me a positive 24. And when I add them together will give me a negative 10, right? So I'm thinking about, how about 6 and 4? Let's see, negative 6 plus negative 4. That's definitely a positive 24. But how about negative 6 plus negative 4? That's a negative 10. I'm done. So now let's rewrite the equation that I have here. So I have 3c squared, but instead of the negative 10c, I'm going to write minus 6c minus 4c plus 8 is equal to 0, right? I have 1, 2, 3, 4 terms here, right? So I want to factor this by grouping. So I'm going to group these together. I have a left-hand group and a right-hand group. On my left-hand group, I have 3c squared minus 6c. Greatest common factor over here is going to be what? 3c. Remember, when you factor out of 3c, it's like you're dividing by 3c. It's like you're dividing by 3c, right? So what's left over? 3 and 3 cancel, c and this. So this is going to become just c. And then over here, negative divided by positive is a negative. 6 divided by 3 is what? 2. And the c's will cancel. I'm looking at the right-hand group now. I have negative 4c plus 8 is equal to 0. The greatest common factor there, I believe, is negative 4. Remember, the sign of your leading term is going to be the sign of your factor, right? Just bringing that back. Anyway, right? I'm factoring out a negative 4, so it's like I'm dividing by negative 4. It's like I'm dividing by negative 4. So now what do I have? Negative 4 will cancel out, leaving back just c. A positive divided by a negative is a negative. 8 divided by 4 is 2, and that will equal 0. After that, let's do greatest common factor here, which will become what? C minus 2. And then what's left over? 3c minus 4 is equal to 0. Now, you already know what I'm going to do, right? I'm going to set both of these equal to 0 individually, right? Our zero product property. So c minus 2 is equal to 0, and 3c minus 4 is equal to 0. And then I just want to solve for c on both sides, right? On my left-hand side, I'm going to add 2. And what I do to one side, I must do to the other. So I have c1 is equal to 2, right? On the right-hand side, this is a 3c minus 4 is equal to 0. I'm going to solve for c by adding 4 over here. What I do to one side, I must do to the other. Now I have 3c is equal to 4. Then I'm going to divide by 3. And what do to one side, do to the other. So now I have c2 is equal to 4 over 3. Right? Just box these in. All right. Is there any questions on this? Anybody? Is it clear? And don't be afraid to ask a question. It's okay. No worries, no judgment. Anything? Okay. Well, I feel like it's time to have a little bit of fun. I understand. Yeah, it is a lot of steps. This next one's not going to be so bad, though. So check this out. We're going to have a little bit of fun with this one. So I have 169q squared is equal to 49. All right. Now, again, want to put this back in standard form, right? So I have ax squared plus bx plus c is equal to 0. That being said, in this question, I'm going to subtract the 49 from over here. Or do the one side, do to the other. So now I have 169q squared minus 49 is equal to 0. All right. After that, let's factor this. Now I notice that this is a difference of two perfect squares. So I'm going to have what? 13q here, 13q here, 7 and 7 here. Then I'm just going to have a plus and a minus. And that's it. That's it. The next step, back to what we were doing before. Set both of them equal to 0. So I have 13q plus 7. Sorry. Equals 0. Then I have 13q minus 7 is equal to 0. In both of these, I want to solve for q. That's simple, to solve for q. So I'm going to do the left-hand side first. I'm going to subtract 7 from over here. Well, I do the one side, do to the other. So I have 13q is equal to negative 7. Then I'm going to divide by 13. Well, I do the one side, do to the other. So I have q is equal to negative 7 over 13. Or at least q1. Let's say it like that, right?
Yeah, how you got 13 out of 169?
So 169 is a perfect square. 13 times 13 is 169.
Oh, okay. So you're just like
Yeah. I just knew it.
on the
Yeah, I just
square
knew
root.
it. Yeah, exactly.
Okay.
If you take 169 and you square root it, you get 13.
All
Exactly.
right. All
Yeah,
right,
yeah,
bet.
yeah. You're
All right,
welcome.
thanks.
Yeah.
And another question: what is the midterms?
So we already took it. We had our first exam.
What? When
Yeah.
was this?
This was on Tuesday. Not this Tuesday that passed, last week Tuesday. Yeah. But it's all
Oh
right.
my God.
If you didn't get a chance to do it, we can always reschedule. Just schedule a time to see me in person. Remember, I'm there Monday, Friday, Saturday, and then we can do the exam.
Yeah, I definitely gonna do that. All right.
Yeah,
My bad. I didn't realize. Oh my God. I've been caught
yeah.
up with so much work and stuff.
I got you. I got you. Ideally, though, if you could do it sometime like tomorrow, Saturday, or even Monday, I'd appreciate it. That way I could get it back to you and
Tomorrow? Yeah,
tell
I do come
everybody.
in the campus tomorrow.
Yeah, yeah, yeah. I'll be here the whole day, 12 to 6, 12 p.m. to 6 p.m. in tutoring.
All
Yeah,
right.
so just come in and like just come in. Just come in and we'll handle
Yeah,
it.
no, definitely.
Yeah.
Yeah. What room? The same room we
Yeah,
be in?
yeah, yeah. No, the tutoring room, CPH 303.
All right, hold on. Let me write that down.
Yeah, CPH 303. I got you.
Thanks.
You're welcome. And if you want to
Alright.
stay afterwards to do homework too, that's cool as well.
Yeah.
Yeah,
All right.
yeah.
Thanks.
You're welcome. You're welcome. All right, back to this, right? So on the right-hand side now, I want to solve for Q. So I'm gonna add 7 over here. What I do to one side, I must do to the other. So I have 13Q is equal to positive 7. Then I'm gonna divide by 13. What I do to one side, do to the other. So I'm gonna call this Q2 is equal to positive 7 over 13. And then that's it. That's the whole answer to the question. You know, if this was web work, like I said, they just ask you to separate it by a comma or something. And that's it. They're not gonna ask you for like Q1, Q2. I'm doing that for your understanding. All right. Like they just asking you for the raw number. Just give me 7 over 13, comma, negative 7 over 13. That's all they're asking you for. And that's it. All right. Questions on this? Anybody? All right, let me give y'all a question. Let me let y'all try. All right, a little bit of an opposite question, right? I did Q, you're gonna do P. All right, so we got 25P squared is equal to 49. So go ahead, solve that. I'll give y'all a minute. Perfect. That looks really good. Good job. All right, let's take a look. All right. So to solve this, I want to put this in standard form once again, just for reminding sake. Standard form is ax squared plus bx plus c is equal to 0, right? In this situation, I have 25p squared is equal to 49. I'm going to subtract 49 from over here. What I do to one side, I must do to the other side of the equation. So now I have 25p squared minus 49 is equal to 0. And then what do I want to do? I want to factor both of these. Set them equal to 0. So this is going to become what? 5p, 5p, 7 and 7. One is positive, one is negative. And then individually, we're going to set both of these equal to 0. So I'm going to have a 5p plus 7 is equal to 0, and a 5p minus 7 is equal to 0. Solve both of them for p. I'm going to subtract 7 from over here. Where I do to one side, do to the other. So I have 5p is equal to negative 7 divided by 5 divided by 5. So I have p is equal to negative 7 over 5. Let me call that p1. And then I have 5p minus 7. I'm going to add 7 over here. Or do to one side, do to the other. So now I have 5p is equal to positive 7 divided by 5 divided by 5. So let's call this p2 is equal to 7 over 5. And there we go. All right, those are our two answers. Questions on this? Anybody? Anybody? Okay. So let's look at a little bit more complicated of a question. All right. But I think you can look at this and figure out what we're gonna do. I think so. Right. So here's what I have. I'm asked to solve 3x minus 8 times x minus 1 is equal to 3x. So what's the first thing that I want to do here? I want to distribute this. Right? Distribute, 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 and distribute, right? So 3x times x is going to give me a 3x squared. 3x minus 1, excuse me, 3x times negative 1 is going to give me a negative 3x. Negative 8 times x is negative 8x. And negative 8 times negative 1 is going to leave me with positive 1. And that's going to be equal to 3x over here, right? After that, let's combine like terms. I have 3x squared minus 11x plus 1 is equal to 3x. After that, I want to subtract 3x from over here. What I do to one side, I must do to the other. So now what do I have? I have 3x squared minus, what's that, 14x plus 1 is equal to 0. After that, let's factor this, right? Let's go straight to the AC method. So a times c will be equal to 3 times 1, which is equal to 3. Where my b term is equal, sorry about that. Where my b term is equal to negative 14. So what does that mean? That means that since my c term is positive, and my b term is negative, that both my answers are negative, right? So I need two numbers that multiply to 3, but add up to 14. Unfortunately, there is none, right? So, I want to answer this question, but, we haven't learned the technique yet on how to do that. We will, but we have to build up to that. We have to build up to that. So this is one of those rare rare times, or I'm going to say let's move on. Only because we don't have that technique as yet. But we will get there. Promise you we will get there. Okay? So take out your notebooks real quick. I want to give y'all some notes. I feel like I owed you this a couple of weeks ago, but I'm giving it to you now. All right? Just a little how-to factor trinomials of the form ax squared plus bx is equal to c using the AC method. Step 1, you factor any greatest common factor. Step 2, you find the product of a times c. Step 3, find two numbers m and n such that when you multiply to a times c, m times n is equal to a times c. And when you add up to b, right? So m plus n must equal b from ax squared plus bx plus c, right? Step 4, split the middle terms using the m and the n. So you get ax squared plus mx plus nx plus c. And then step 5, factor by grouping. And then step 6, you can check that your answer is right by multiplying the factors. All right? Okay. Just want to give you guys a little bit of notes there. Let's see something. One second. All right, let's take a look at this question. I feel like this question is a little bit nicer. Apologize, I was just kind of working it out a little bit. But anyway, right? I want to use the AC method here, but I have to multiply this out, combine like terms, and I'll be able to. So first things first, let's distribute. So k times k will give me a k squared. K times -1 will give me a negative k. 1 times k will give me a positive k. And 1 times -1 will give me a -1, which is equal to 8. Combining like terms, I have k squared minus 1 is equal to 8. Subtract 8 from both sides. So I do to one side, do to the other. So now I have k squared minus 9 is equal to 0. And you already know what's going to happen. I'm going to factor this. This is going to become k minus 3. K plus 3 is equal to 0. I want to set both of these equal to 0. So I have k minus 3 is equal to 0. K plus 3 is equal to 0. Add 3 to both sides. So I have k is equal to positive 3. Subtract 3 from both sides. So I have k is equal to negative 3. Let's call that k2. Let's call that k1. That's it in a nutshell. Right there. All right. Let's try another one. Let's look at this. All right, I have 3x squared equals 12x plus 63. Remember, I want it in the standard form, ax squared plus bx plus c, right? So I'm going to move everything to the other side. So I'm going to subtract 12x from over here. What I do to one side, I must do to the other. So now I have 3x squared minus 12x is equal to 63. And I want to subtract 63 from over here. What I do to one side, I must do to the other. So now what do I have? 3x squared minus 12x minus 63 equals 0. All right. Now, before I do anything here, let me inspect it. Do I have a greatest common factor here? Is there a number that or a variable that goes into all three terms? Oh, sorry about that. Good. So I'm going to factor out a 3 over here. And then what's left over? Sorry about that. All right, so remember, it's like you're dividing by 3, like you're dividing by 3, like you're dividing by 3. So the 3's here will cancel out, leaving back x squared. A negative divided by a positive is a negative, and 12 divided by 3 is 4, leaving back that x. All right, a negative divided by a positive is a negative, right? And 63 divided by 3 is like 21. Excuse me, and that's equal to 0. So now we're going to factor this as usual. You can use the AC method. In this case, I will feel like using the trial and error method for time reasons. So I should have x minus, I want to say 7 and x plus 3. All right? Boom. Oops, sorry for the extra parentheses. And then that's it. You want to set both of these equal to 0. So I'm going to have an x minus 7 equals 0. X plus 3 equals 0. And then you're going to solve for x. Add 7. So x is equal to 7. And I want to subtract 3 over here. Call this x1, call this x2 is equal to -3. All right. Questions on this? All right. If there's no questions, you guys try. All right. Remember, first thing I want to do, I want to get this in standard form. So ax squared plus bx plus c. Over here is not. So what am I going to do? Move everything to the right. So I'm going to add 33a over here. But what I do to one side, must do to the other. What do I have? 18a squared plus 33a minus 30 is equal to 0. Before you solve this, look and see, is there a greatest common factor here? Right? I'm thinking about 3. Thinking about 3. So I know that when I factor out 3, it's like I'm dividing by 3. So 18 divided by 3, what's that? I think that's about 6a squared. Positive divided by positive is positive. 33 divided by 11 by 3 is 11a. And then minus, and then what is this? 10 is equal to 0. After that, let's factor it. You can use your AC method at this point. So A times C is equal to 6 times negative 10. Let's call that negative 60. And my B term is equal to 11. So I want two numbers that multiply to a negative number and add up to a positive 11. So a little bit of a reverse. Our leading term will be the Let's say that again. So a little bit of a reverse, right? I want two numbers that multiply to negative 60 and add up to 11. All right? One is going to be positive, one's going to be negative. The larger number will be positive. So, thinking. This is a good question. I have 60, 610, 25, 32. So 15 and 4. That's it. So this is going to be 6a squared plus 15a minus 4a minus 10 is equal to 0. Then you want to split these. So I'm going to have 3 on the outside times greatest common factor here is going to be 3a. Or it's like you're dividing by 3a. And then we have what? 2a. Yeah. 2a. Positive divided by positive is a positive. 15 divided by 3 is 5. A's will cancel over here. Right-hand side, pull out a negative 4. So now the negative 4s will cancel out, leaving back a. Negative divided by negative is a positive. 10 divided by 4. Yeah, that's good. Something about this don't feel right. Hold up. It's not negative 4. My mistake. Negative 2. That's our factor. Sorry about that. I'm going to erase this tree. You guys can grab that back in the recording. Negative 2, right? So this is going to give me a 2a, and a negative by negative is a positive. 10 divided by 2 is 5. There we go. Sorry about that, you guys. Greatest common factor, we're going to have 3 times 2a plus 5 times the 3a minus 2. Again, this is always an equation, equals 0. Let's set both of these individually equal to 0. So I have 2a plus 5 is equal to 0, and 3a minus 2 is equal to 0. I'm going to subtract 5 from over here. What I do to one side, do to the other. So I have 2a minus 5, 2a is equal to negative 5. Divide by 2, divide by 2. So I have a is equal to negative 5 over 2. Let's call that a1. On the other side, right-hand side, I'm going to add 2. What I do to one side, I must do to the other. So I have 3a is equal to 2. I'm going to divide by 3. What I do to one side, do to the other. So a2 is equal to 2 over 3. These will be my factors, and that's that. Any questions on that? Anybody, any questions? All right, there's no questions. Let's jump into something else. Another example. I want you guys to have all these examples so that you can reference it in the future. Well, for homework, at least. Moving. All right, check this out. Check this out, check this out, check this out, check this out. So I have 9m cubed plus 100m is equal to 60m squared, right? So now what do I want to do here? Right? Remember what I said, right? We wanted this in standard form. Let me write the standard form up here again, just to remind. This is ax squared plus bx plus c is equal to 0. That's our standard form. In this case, I have 9m cubed plus 100m is equal to 60m squared. I'm going to subtract the 60m squared from over here. And what I do to one side, I must do to the other. I'm going to put this in descending order. So this becomes 9m cubed minus 60m squared plus 100m is equal to 0. Just like that. Just like that. After that, let's do a greatest common factor here. I want to do a greatest common factor here. So I find that I have m on the outside. This is going to leave back what? 9m squared minus 60m plus 100. And that is going to be equal to 0. All right, just to remind you guys that when I factor out the m, it's like I'm dividing by m, in case you didn't see it. Anyway, I have a perfect square trinomial right here, right? 9m squared is a perfect square, 100 is a perfect square, right? So I'm going to use our trick to factor this. But once again, you can use the AC method, no problem, right? You don't have to memorize the trick if you want. How do we get 3a? Hold on one second. I'm sorry. Let me come back up here. So we had 6a squared plus 15a. All right, apologize for the late answer. We have 6a squared plus 15a. The greatest common factor there was 3a. So that's where the 3a came from. All right. Sorry about that. Sorry about that. That's where the 3a came from. And then so on and so forth. All right. And back to this question real quick. I have a perfect square trinomial here. So I'm going to use our trick, right? Our b term is negative. So this is going to be what? 3m minus square root of 100 is just 10. This whole thing squared is equal to 0. Just like that. Just like that. I'm going to have two answers here. I'm going to set both of these equal to 0. So I have m1 is equal to 0, and I'm done with this. That's it. All right. Last but not least, I'm going to have a 3m minus 10 is equal to 0. And there is also a third term here. There is another 3m minus 10 is equal to 0. But they're going to give me the same answer, right? So I'm just going to, I'll do it twice so that you can see what's going to happen. Let me do it twice. So I'm going to add 10 over here. I do to one side, do to the other. So now I have 3m is equal to 10. I'm going to divide by 3, divide by 3. So I have m2 is equal to the 10 over 3, right? And then over here, I'm going to add 10, add 10. So I have the 3m is equal to 10. I'm going to divide by 3, divide by 3. So m3 is equal to the 10 over 3. These are the same. Hold on one second. M1 is equal to 0. All right. Those last two are the same, right? But if this was web work, you'd only enter it in one time, right? You'd only enter it in one time. All right. If this was a test and you just gave me the first two, I understand that you're using a trick. I would take that as the full answer. I'll give you full credit for that. Okay. But understand that there's three answers. One answer has a multiplicity of 2, so it repeats itself. That's all that that means. All right. Some big vocabulary words are being dropped on you. You will learn more about that when you get to Math 30. Okay, until then, let me let you guys try a question for yourself. Go right ahead. Try that out, try that out, try that out. All right, so we're trying this one out. All right, let's try this out. Let's try this out. I have 8x cubed is equal to 24x squared minus 18x, right? So what happens now? I want to solve for x, right? I want to solve for x. So remember, I want to put this in standard form. And standard form is ax squared plus bx plus c is equal to 0. So for my 8x cubed equal to 24x squared minus 18x, what do I want to do? I want to move everything over to the same side and set it equal to 0. So I'm going to subtract the 24x squared here. What I do to one side, I must do to the other. So now I have 8x cubed minus 24x squared is equal to negative 18x. And then I want to add an 18x over here. But what I do to one side, I must do to the other. So now let's look at what I have, right? Let's put it all together. I have 8x cubed minus 24x squared plus 18x is equal to 0, right? After that, I'm looking for now a greatest common factor, a number that could go into each one of these, or a number and a variable that can go into each one of these terms. All right, I'm going to start off with 2x. I could kind of look at that and just see 2x is a very nice factor, right? So now remember, when I factor out of 2x, like I'm dividing by 2x. It's like I'm dividing by 2x. It's like I'm dividing by 2x, right? Let's go through it. 8 divided by 2 is 4. The x and the cube will cancel out, leaving back what? X squared. A negative divided by positive is a negative. 24 divided by 2 is 12. The x and the square will cancel out, leaving back just x. And then 18, a positive 18 divided by a positive 2 is going to give me a positive 9. And then the x's will cancel out. And then I'll be left with equals 0, right? Wow, look at this. I have another perfect square trinomial. So let's use our trick, right? If you're not comfortable with the trick, use the AC method. It will give you the same answer. Don't worry, right? So for our trick, we already know what's going to happen here. This is going to be 2x and 2x. This will be 3 and 3. One will be negative, and the other one will also be negative. And that's it. That's it. Now, individually, I want to set each one of these equal to 0. So I have 2x is equal to 0. I have 2x minus 3 is equal to 0. And I'm going to have another 2x minus 3 is equal to 0. And I want to solve for x in each one of them. So I'm going to divide by 2. What I do to one side, I do to the other. So I have x1 is equal to 0. I'm going to add 3 over here. What I do to one side, I must do to the other. So I have a 2x is equal to 3. I'm going to divide by 2. I do to one side, do to the other. So I have x1 is equal to 3 over 2. Let me do it again. I'm going to add 3 over here. Where I do to one side, do to the other. So now I have a 2x is equal to 3. I'm going to divide by 2. What I do to one side, I must do to the other. So I have x2 is equal to 3 over 2. These, excuse me, are my answers, right? Once again, if it was a test and you just gave me 2 of them, the 0 and the 3 over 2, I would give you full credit for that because of the multiplicity. All right. So something else I want to talk about real quick. So we want to solve equations with polynomial functions, right? So as our study of polynomial functions continues, it will often be important to know when the function will have a certain value or what points lie on the graph of the function, right? So our work with the zero product property will help us to find these answers, all right? There we go. So this is the type of question that I'm kind of hinting at. Just gonna say it out bluntly, right? So let's say that we have a function, f of x is equal to x squared plus 2x minus 2. We want to find our value for x when f of x is equal to 6. All right, and then part 2 says to find 2 points that lie on the graph. Very simple to do. I'm going to show you guys. We know how to do both of these already. So I have f of x is equal to x squared plus 2x. Let me write that down. X squared plus 2x minus 2, right? And we notice that f of x is equal to that, but f of x is also equal to 6. That means that I can equal these two together. And boom, we're right back where we started from before, right? Solve for x. So what's the first thing I'm going to do? I'm going to subtract 6 from over here. What I do to one side, I must do to the other. So now what do I have? X squared plus 2x minus 8 is equal to 0. After that, just factor it, right? No stress, no stress. So this is going to become what? X plus 4, x minus 2, right? You guys can confirm that using the AC method if you like, right? Very simply, after that, we're going to set both of these equal to 0. So x plus 4 is equal to 0, right? And x minus 2 is equal to 0. So I'm going to subtract 4 from over here. Where I do to one side, do to the other. So I have x1 is equal to negative 4. I'm going to add 2 over here. What I do to one side, I must do to the other. So I have x2 is equal to 2. These are my answers, all right, to the question. Think of this as part A. That's part A. Part B says find 2 points that lie on the graph, right? 2 points that lie on the graph. So, hold on, where's my mouse? Okay, there we go, there we go. So 2 points that lie on the graph. I'm going to change my color up for this one. I'm going to go with this one, right? So for part B, they want 2 points that lie on the graph. You can pick whatever you want, right? Whatever you want, right? So I have f of x is equal to x squared plus 2x minus 2. I'm going to pick something very simple. I'm going to do f of 0. So what happens there? This is going to become 0 squared plus 2 times 0 minus 2. When we do the math on all of that, we have that is equal to negative 2, right? So this would be one answer. Another answer, keep it simple. I'm just going to pick one, right? I can pick any number I want. I just want to keep it simple, right? So this is going to be 1 squared plus 2 times 1 minus 2. And what does this become? 1 plus 2 minus 2, which will give me 3 minus 2. And then let's just call that 1. And that's it. This will be my other answer. Very nice, very simple. All right. Is there any questions on this? Any questions at all? Anybody? All right. If there's no questions on that, I'm going to let you guys try one. All right. This will be a lovely topic that will come up in Math 30. Getting you guys prepared for that. Not very complicated, but very useful. All right. Give you guys a minute, let you guys try that. All right, all right. Let's give this a try. Again, not very complicated, but useful, right? So for the function f of x is equal to x squared minus 2x minus 8, I'm going to write that down. X squared minus 2x minus 8, right? I'm going to set that equal to 7 because I want to find x when f of x is equal to 7, right? We're right back in the ballpark where we started from, right? I'm going to subtract 7 from over here. What I do to one side, I must do to the other. So now I have x squared minus 2x minus 15 is equal to 0, right? After you see this, just factor it, right? I'm just going to do this in my head real quick. This is going to be x minus 5, x plus 3 is equal to 0, right? You can use the AC method to verify later if you like, all right? After that, we want to set both of these individually equal to 0. So this is going to become x minus 5 is equal to 0, and x plus 3 is equal to 0, right? I'm going to add 5 over here. Where I do to one side, I do to the other. So now I have x1 is equal to 5. Then I'm going to subtract 3 from over here. Where I do to one side, I must do to the other. So I have x2 is equal to negative 3. These are my answers. Very simple. And that's A, by the way. That's A. All right. For B, they're asking you a very simple question. They want to know, right? 2 points that lie on the graph of the function, right? So if f of x is equal to x squared minus 2x minus 8, right? I could pick whatever points I want. Just going to keep it simple, right? Let's pick f of 0. Keep it simple. So this becomes what? 0 squared minus 2 times 0 minus 8. So we already know that this is just going to come out to be what? Negative 8. And there you go. That's 1 point. Let's get another point. Let's get another point. Keep it simple. I'm just going to do 1. Let's say f of 1. This is going to become 1 squared minus 2 times 1 minus 8. Let's do the math on that. This is going to become 1 minus 2 minus 8. Let's subtract this out. This is going to become, I think, negative 1 minus 8. And then finally, negative 9. That's simple. And that's it. Is there any questions on this, please? Anybody? Any questions? Any questions? All right, I just want to finish off with some notes real quick. And then that'll be it. I'm not going to give you an example for these notes because I feel like we're kind of crossing that line into Math 30. But you guys will learn this, but I feel like it's nice that this should be said, right? So the zero product property also helps us determine where the function is 0. A value of x where the function is 0 is called a 0 of the function. So 0 of a function for any function f is f. If f of x is equal to 0, then x is a 0 of the function, basically, right? So you set the function equal to 0, and that's one of the zeros of the function, right? Let's elaborate on that just a little bit. Just telling you guys something. So when f of x is equal to 0, the point x comma 0 is a point on the graph. This point is an x-intercept of the graph. And it is often important to know where the graph of the function crosses the axis, right? So we will see some examples of that, right? Or you will see examples of that in Math 30, all right? Like, long story short, this is what I'm hinting at right here. Some of you might remember seeing things like when you have a x and a y plane, having a parabola, and the parabola crosses at a point, right? It crosses the x-axis at a point, right? This point would be x comma 0, and this point would also be x comma 0, right? That's what this is referring to. Those points where the graph will cross the x-axis when y is equal to 0. All right. But again, diverging a little bit, that's where you're going to pick that up in Math 30. But I wanted to make that link for you guys right now. And then that's it. So that's it for today. I'll be happy to take any questions from anybody. If you guys have homework questions you guys want to look at, anything, good time to ask, good time to go over anything right now. All right. Once again, just want to repeat, we took our test last week, right? Yeah, last week. And test has been graded. All right. So if you guys want that test grade back early, please see me in tutoring. I'll be in person tomorrow from 12 to 6. I'll be in person on Saturday from 3 to 6, and Monday all day. Just come in, say, hey, professor, you have the test. I'll give it back to you, and then that's it. All right. If you guys don't want to do that, on Tuesday when you come in person, I got you. I'll give it back right then and there. All right. Please stay on top of your homework. All right. You guys are all welcome to tutoring. All right. You're all welcome to tutoring, whether it's in person or online. Please take advantage. All right. I want you guys to get all the knowledge, get all the help that you can. Right. There's no reason for any of us to have to fail this class or even drop the class or anything like that. I believe in all of you. Everybody can pass. All right. Please don't suffer in silence. Ask for help. There's no shame in doing that. I did it when I was a student. All right. You're all welcome to do so. Okay. Remember that next week will be pantry, so you guys plan accordingly. I'll drop the form in the announcement for those of you that haven't gone as yet. All right. And that's it. Means anybody have any other questions? Anything you guys would like to go over? Be happy to do that. You're welcome. You're welcome. And thank you for coming. Thank you for coming. All right. Awesome. Awesome. All right. And also, if you look at the is it the last announcement? No, the announcement before last, I believe, and maybe last announcement as well. I have the review sheet attached there, right? So you guys can so you can look at the review sheet before the exam. You can take it tomorrow, no problem. All right. Also, like, that whatever we did today is not on the test as well, right? So I'm talking about this is going to be older material that's on the test. Just come, bring like a pencil, a pen, and bring your calculator. Right? No, I have paper, don't worry. I got you. I have paper. All right.
All right, so hello?
Yeah, I'm here. No problem. I can hear you.
Is it wait, I'm confused. The class ending?
Yeah, that's it. That's it for today. I mean, if you
Oh,
have any questions though, like you want to do some homework right now or something, we could do that.
I'm about to do that right now. Yeah, I was gonna do that.
Yeah. I'm gonna be in tutoring online today at 5. So if you guys want to make an appointment on WC to see me, that's legal too. You could do that as well.
All right.
Yeah. Yeah, I'm gonna be there till 8 o'clock tonight, by the way.
All right, bet. So if I'm struggling, I come by.
Yeah. No problem. No problem.
All right. See you, sir. Have a good day.
All right, I'll see you. Have a great day. Have a great day. And have a great night as well.
You
Yeah,
too.
thanks. Yeah. And I promise I'll post the recording. I'm just gonna ask you guys for a little bit of time with posting the recording. Right. It does take time to download and upload and everything like that. All right. Well, I see everybody is dipping right now, so I will see you guys. All right. So have a great night. All right. I'll see you guys next week on Tuesday. All right, where I'll hand back the test and then we'll move forward from there. All right. Please, everybody be in class on Tuesday to get back your test. All right. Have a great weekend. Talk to you soon.